All right, this is Mr. Anderson for Kellogg Community College, and this is another video, or our second part of videos talking about equations with factors, or sorry, equations with fractions. We're going to deal with some really interesting problems here. These 5 problems on this page are going to kind of encapsulate some of the more tougher ones that we have here. So let me center this a little bit more for us and get started. Okay, so like in the previous video, we are going to first look for numbers that could give us a division of 0 error, but I'm looking at the second fraction right there. Yeah, you see that denominator? It doesn't look great, and it doesn't look great because we usually have the x in front. Well, one of the things I taught in an earlier section is the flip property, which is allowing you to factor out a -1 and change the order of your problem so the x is in front positive and the other number is negative. I mean, if this is a plus, we just switch it around, but since it's a minus, you can't switch that around. So let me kind of take this off to the side a little bit and show you what I'm going to do. In the denominator, I'm going to pull out a -1, which makes this a -1 plus 3x under the -2. Then what I get to do is I get to rewrite this as 3x minus 1 instead of -1 plus 3x. Now the negative and the negative, two negatives divided by each other make a positive, so this becomes a positive 2. So this problem over here on this side, I'm going to rewrite it as 2 over 3x minus 1. It'll make things a lot easier when I do the problem. One part of it is looking for numbers that could give me a division of 0 error, and in this case that would be 1/4, and it would be 1/3. Because if I plug those either of those numbers in, one of those denominators would turn into 0, and you can't have a division of 0 error. The lowest common denominator, now the next step is to find the lowest common denominator of the problem, and it's basically one of each of the binomials in the denominator. So our next step, this is our third step, but actually second step on the previous page, is we multiply the numerator by these common denominators. So the 4x minus 1 and the 3x minus 1, and the 4x minus 1 and the 3x minus 1, and then we start simplifying. Now, for those of you who are first coming to this video, you might say, hey, he's just doing cross multiplication. You're right, and this is why cross multiplication works. It's multiplying by both denominators, and you simplify or cancel the denominator that is similar to it. And what you're left with is this distribution problem here. So this is 12x minus 4, and over here this is going to be 8x minus 2. We're going to move the 8 to the other side, so if we subtract 8 from the 12, we get 4x. If we add 4 to the 2, we get a positive 2. Divide both sides by divide both sides by 4, yikes, and then we get x is equal to 2/4 or 1/2. You'll note that 1/2 is my answer, and it doesn't conflict with one of these danger numbers, so the answer checks out. You could also plug this into the fraction and go like 4 divided by 4/2 minus 1 is the same as 2 divided by 3/2 minus 1, and you could see that they are equivalent. The lowest common denominator here is x plus 12, x plus 4. You also can get your danger numbers where x is not equal to 12, or sorry, -12, and -4. These are our two danger numbers, -12 and -4. So like we did in the problem up above, I'm going to multiply top of the problem by x plus 12, x plus 4. And simplify or cancel with what was left down there. And so here's another simplification. So now in this case, you'll note that the first term is an x. So when I multiply it by x plus 4, I get x squared plus 4x. Here I'm going to multiply by 2, so this is 2x plus 24. Well, I'm going to move some things over to the other side because, as we learned in the previous chapter, if you have an x and an x squared, you're going to have to factor or use quadratic formula, but we haven't done quadratic formula yet. So I'm going to subtract the 2x from both sides, also subtract the 24 from both sides. So here's what we have. We have 0 is equal to x squared plus 2x, x squared plus 2x minus 24. And now our job is to, oh, I wrote 24 twice. Wow, what's up with that? All right, so let's rewrite that again so it looks a little nicer. X squared plus 2x minus 24. And now I'm going to solve this simple trinomial to solve here. What two numbers multiply to make 24 and add to make 2? And the answers in this case are negative 4 and positive 6. Because 6 times 4 is, 6 times negative 4 is negative 24. And if you add them up, you get an answer of 2. And so my answer here is x is going to be equal to 4, and x is going to be equal to negative 6. I have two possible answers that I can plug into this equation and get my correct answer. Now, if you're wondering how did I jump from here to here, I just set either of those equal to 0 and got my answer that way. So there's an example of how I got this one, and you would go x plus 6 equals 0 and then, solve for x. So I have two answers that do not conflict with either of these danger numbers here or excluded values, and you can try plugging it in. 4 over 4 plus 12 is equal to 2 over 4 plus 4, or negative 6 over negative 6 plus 12 is equal to 2 over negative 6 plus 4. We're going to kind of approach an interesting problem. Problem number 8 is a good one to talk about here. Problem number 8 is going to have an issue. So let's first of all figure out what our lowest common denominator is, which is nice since there's only one of them, and also talk about our danger number. So x cannot be equal to 3, because if I plug 3 into either of these fractions, I get division of 0 error. So I'm going to multiply each of these by x minus 3. The problem looks worse than it actually is in terms of its work or setup, because there are so many x minus 3's. What you get here is 2x minus 6 plus 3 equals x. So, I mean, because these simplify, so the 3 stays itself, and these simplify, so the x stays itself. So now what we'll do is we'll go 2x, this negative 6 plus 3 is equal to negative 3 equals x. And then I'm going to subtract the 2x from both sides. So I'm going to have my negative 3 is equal to negative 1x, or just negative x, divided by negative 1, x is equal to 3. Now, in this situation, you'll note that the answer, x equals 3, is a problem, because now, over here on this side, it's the danger number, so my answer is no solution. There is no solution to problem number 8, the one I have written here, because you just can't have an answer that would give you a division of 0 error. So sure, yeah, the numerator would be great if I could put a 3 up there, but 3 divided by 3 minus 3 is 0, division of 0 error, so you can't do it. So let's look at the next problem and see if that trap happens, or trick happens. Here's a lowest common denominator is x minus 2. X cannot be equal to 2. So let's see what happens. So I'm going to multiply everything by x minus 2, and we'll just see. And I'll draw a little line here to not get those two confused. All right, so we got a little simplification there, and now we're going to distribute the negative 3. So this is negative 3x plus 6. Now, if you look at common terms here, you'll note that these two do simplify, so x is equal to 6. Hey, no conflicts. All right, 6 is the answer to the problem. So we have 6 over 6 minus 2 is the same thing as 3 times 6 over 6 minus 2 minus 3. And you can type that into your technology and check your work. And so for our final problem today, let's go and look at it here. For our final problem today, this is going to take us down a pretty difficult run of factoring. Our lowest common denominator is x and x minus 1. That means our values of x can't be 0 or positive 1, because that would give us a division of 0 error. That means each one of these fractions has to be multiplied by x and x minus 1, x and x minus 1, x and x minus 1. I call them balloons in class because we can pop the balloons, and whatever's left over gets multiplied by that other number that's left. So I pop this balloon, and this is going to then be 6x minus 6. And none of these balloons get popped, so this is technically 2x times x minus 1. So we're going to have a negative 2x, and then we're going to have the negative 2x times the negative 1, so This is, oh, sorry, a little squared there. Sorry, let me start over. This is negative 2x times x, so that's negative 2x squared. Then negative 2x times negative 1, so this is positive 2x. Well, it's time to factor because we have an x squared and we have an x, so the only way to go about this is factoring. And I know you might want to move the x to the other side here, but since we have a negative x squared, my inclination is to collect like terms and then move everything to the left. So this is going to be 8x minus 6 minus 2x squared. Let's move this 2x squared to the other side. And the reason why is I want to really deal with a 2x squared rather than a negative 2x squared. I know I could have divided everything by negative 1, but I'll just kind of stay consistent. I'm going to move the 8x over here, and also I'm going to move the 6 over here as well. So all three of these go away with what I'm manipulating, and that leaves me with 0. Over here I got 2x. I've squared minus 7x plus 6. And you're wondering, where'd the 7 come from? Because there's 1x already on the left side, so 1x minus 8x is 7x. And lo and behold, here we have a tricky trinomial. It is factorable. This tricky trinomial is factorable, and how we do that is go to my scratch work over here, and 2 times 6 is 12. Now I've got to find two numbers that multiply to make 12 and add to make negative 7. That's pretty easy. It's negative 3 and negative 4. That makes a positive 12 when I multiply them, and a negative 7 when I add them. So I split this up into negative 3x minus 4x. I also could have had negative 4x minus 3x. And I get a 4-term problem. And what we learned in the factoring chapter earlier than this is that when you have a 4-term problem, the only thing you can do is group. So we're going to remove the x, which gives me 2x minus 3. I'm going to factor out a negative 2, which gives me 2x minus 3. And so now what I have left is x minus 2, and 2x minus 3 is equal to 0. I now can find out when x hits the ground or when x is equal to 0. So I can set each of these equal to 0, and I'll find out my first answer is x equals 2. And here, just to show this out, if I set that equal to 0, I would add 3 to both sides, and then divide by 2. Those of you might have learned a pattern by now about when these hit the ground and when danger numbers are formed, but you'll see that both of these answers do not violate the danger numbers over here. So you can come over to this problem and have 1 over 2 minus 1 is equal to 6 over 2 minus 2, which is basically 1 is equal to 1. And I also will have 1 over 3 halves minus 1 is the same thing as 6 divided by 3 halves minus 2. And I would dare say you may want to use a technology to figure that out or to do that, since I'm not going to do that in my head right now. But I want to thank you for watching the video here. This is the part 2 of solving equations with fractions. I keep saying factors. Have a good one. Thank you.